Welcome back to another explainer. Today we are looking at something absolutely mind-blowing, the Argentinosaurus. We're going to break down the sheer, staggering scale of this South American titan and really dig into the biomechanics of how a giant this massive actually managed to survive.
You know, we've all heard of massive prehistoric creatures, right? Take the Titanoboa, for instance, the largest snake ever discovered, and a true monster of the ancient swamps. But as terrifying as that apex predator was, its physical footprint was completely dwarfed by Earth's true giant. When we look at the historical timeline of colossal animals, the baseline we usually use to define massive often falls incredibly short. Well, we are about to completely shatter that baseline today, because our titan was so unimaginably enormous that even the absolute largest land animals we know of today would literally look like just background details next to it.
So to really understand this creature, we have to travel back to prehistoric South America during the late Cretaceous period, millions of years before humans even existed. This was a pristine, highly volatile ecosystem built for creatures of colossal proportions. Picture a biologically rich landscape packed with towering forests and sprawling floodplains. I mean, it had to be, right? It had to provide the immense resources needed to support extreme gigantism. And right in the heart of this highly competitive ancient world is where the Argentinosaurus reigns supreme, navigating an environment vastly different from anything we see today.
Now, when we talk about Argentinosaurus, scientists aren't just categorizing another large dinosaur. No, they consider it to be one of the absolute biggest land animals to ever live. Of all the species that have walked the Earth, this creature pushed the very limits of biological engineering on land. Just think about it. Maintaining a terrestrial body of this magnitude requires some crazy evolutionary adaptations. Bone density, cardiovascular output, weight distribution. It wasn't just big, it was a total masterclass in biomechanical efficiency. It literally tested the physical constraints of what a land-based environment can actually support.
All right, let's break down the actual blueprint. Get a load of this number, 115. Argentinosaurus reached a staggering 115 feet. That's roughly 35 meters in total length. To put that into perspective, imagine standing at the edge of a professional basketball court. If you looked all the way past the opposite hoop, this animal would still stretch beyond it. When you analyze a skeleton capable of spanning that kind of distance, you start to realize the incredible demands on its nervous system. Just sending a simple sensory signal from its tail all the way up to its brain was a massive physiological feat in itself.
But you know, length is just one dimension. Check out this next number, 70. This animal weighed somewhere between 60 and 70 tons. That mass is the equivalent of an entire fleet of modern school buses packed into a single living, breathing organism. The gravitational reality of a land animal carrying that much weight is almost hard to wrap your head around. I mean, supporting 70 tons of muscle, organs, and tissue against Earth's gravity, that required legs built like solid columns of reinforced concrete. Its skeletal architecture had to be perfectly designed to distribute all that incredible pressure, otherwise it would literally fracture under its own immense weight.
And that massive weight wasn't just stretched out horizontally either. It was projected vertically, way up into the canopy. Argentinosaurus possessed a neck that extended as high as a 4-story building. Picture yourself standing on the sidewalk, looking all the way up at the roof of a 4-story apartment complex. That is where this creature's head was operating. From a biomechanical standpoint, pumping blood way up to a brain at that elevation requires a seriously powerful cardiovascular system. It effectively acted as an immense biological engine, just to keep the animal conscious while it effortlessly munched on leaves from the highest prehistoric trees.
Because of all this, scientists actually note that every step it took shook the ground beneath it. Think about the sheer kinetic force required to lift a pillar-like leg supporting 70 tons and then bring it back down. This isn't just some dramatic description. It's a real measure of extreme energy displacement. If you were anywhere nearby, you wouldn't just see this creature coming, you would physically feel the heavy, deliberate vibrations of a literal walking earthquake. Actually, the structural integrity of its footpads had to be highly specialized just to absorb that kind of constant shockwave, protecting its joints from the devastating impact of simply walking around.
So fueling a 70-ton, ground-shaking organism obviously requires an astronomical amount of energy. But here's the crazy part. As an herbivore, sustaining that mountainous mass was a profound logistical marvel. It survived entirely on plants. It had to constantly strip vegetation from those 4-story canopies, processing massive volumes of plant matter every single day just to keep its metabolic engine running. We are talking about tens of thousands of calories required daily. That demands a highly efficient, enormous digestive tract capable of fermenting and extracting every last possible nutrient from tough, fibrous prehistoric flora.
Which brings us to a really interesting question about the ecological dynamics of its environment. When a land animal is essentially a walking mountain of muscle and bone, does anything in the high-stakes world of late Cretaceous South America actually pose a threat? Did it have any enemies? To figure this out, we have to look at apex positioning and the predatory hierarchy of that ecosystem. We have to ask ourselves if sheer size alone acts as an absolute deterrent against highly evolved coordinated carnivores sharing the exact same territory.
Well, the reality of survival back then was a tale of two absolute extremes. At full size, a healthy adult Argentinosaurus was virtually untouchable. It was biomechanically impossible for a single predator to bring one down without risking immediate lethal injury. But long before they grew into those 115-foot titans, the young faced a vastly different reality. They hatched small, meaning they had to undergo periods of incredibly rapid, resource-intensive growth. And during that prolonged developmental window, they were extremely vulnerable targets in a ruthless, highly competitive ecosystem.
This extreme size gap completely dictated predator behavior and evolutionary hunting strategies. Cunning, opportunistic, meat-eating dinosaurs understood the fatal risk of engaging the adults, so they essentially ignored the fully grown titans entirely. Instead, they actively bypassed those untouchable adults to systematically hunt the vulnerable young. It really highlights a brutal ecological reality. In this environment, even the lineage of the biggest giant wasn't completely safe. Not until an individual successfully survived the deadly gauntlet of youth, relying on immense growth rates to quickly outpace the threat of being eaten.
Now, zooming out from that ancient struggle to the present day, we find something incredibly striking about this animal's legacy. Today, only a few fossils remain. It's kind of wild when you think about it. For an organism that completely dominated its physical environment, displacing Earth with its footsteps and clearing out vast swaths of canopy vegetation, it left behind surprisingly few physical traces, just a scattered, localized collection of massive vertebrae and limb bones, buried deep in the South American rock, just waiting millions of years to be uncovered by modern science.
But the scientific relevance of those sparse fossils absolutely cannot be overstated. Even though we only have a fragmented physical record, those remains prove a staggering reality. Earth was once home to animals vastly larger than anything walking on land today. Those few surviving bones confirm that our planet's ecological and atmospheric history was capable of engineering absolute biological marvels. They challenge our entire understanding of terrestrial limits, and they firmly place Argentinosaurus as one of the greatest biomechanical achievements in all of natural history.
So, this leaves us with a truly compelling ecological question to end on. We've established the scale, the biomechanics, and the survival logistics of the ultimate heavyweight champion of the herbivores. But if Argentinosaurus was the absolute biggest, who is the deadliest? If you were a highly evolved predator operating in the prehistoric world, what specific evolutionary traits did it take to truly rule your domain?
Well, in our next explainer, we are going to uncover the truth about exactly that, the Tyrannosaurus rex, the king of predators. It's a completely different side of prehistoric survival, focusing on bite force, sensory adaptations, and predatory dominance. Make sure you hit subscribe and join us next time as we continue decoding Earth's greatest natural mysteries together. See you then.